So let's continue to explore trigonometric functions, this time of an acute angle. And what this is going to allow us to do is explore our 6 trigonometric ratios. And the trigonometric ratios come from previous classes. You might remember this as SOHCAHTOA, where we have a right-angled triangle, and we want to find all of the trig ratios associated with this acute angle. Now it's acute angle because it's less than 90, so let's just call the angle theta. And if you recall, the theta is that angle. This would be the opposite, the adjacent, and the hypotenuse. And that would allow us to do our SOHCAHTOA. So sine of the angle is the opposite over the hypotenuse. Cosine of an angle is adjacent over hypotenuse. And tan of the angle is opposite over adjacent. And there's our 3 trig ratios from SOHCAHTOA. Now there's actually other trig ratios associated with the reciprocal of these ratios. So if we were to take the reciprocal of sine, that's 1 over sine, and the reciprocal would then be the hypotenuse over the opposite. Just flip that fraction around. Same thing with cos. Instead of cos theta, we'll do 1 over cos theta. This flips that fraction, and we get the hypotenuse over the adjacent. And 1 over tan theta is adjacent over opposite. Now these reciprocal ratios have their own names. Now you may have seen these before, you may not have, but this ratio of hypotenuse over opposite is called the cosecant of an angle. Hypotenuse over adjacent is called the secant of an angle, and adjacent over opposite is called the cotangent. So 3 potentially new trig ratios. Now these are abbreviated. Cosecant is CSC theta. Secant is SEC theta. And cotangent is COT theta. So we're actually going to write, instead of writing 1 over sine, we're just going to call it cosecant, and the same for all of those other reciprocal identities. Now this will allow us to now solve the triangle with 6 different trig ratios. Now we can also take these 6 trig ratios and we can define them in terms of some point xy. Some point xy. So let's just draw in our terminal arm. Here's our terminal arm. We're out here at some point P, which is an xy coordinate. And from that xy coordinate, we can draw in a triangle, just like so. And on this triangle, the opposite in relation to this angle is y. The adjacent is x. And what we're going to do is we're going to call this hypotenuse, instead of hypotenuse, r for the radial arm or radius. And this will now allow us to write our angles in terms of x, y, and r. So the sine of the angle is the opposite, in this case, which is y, over the hypotenuse, which is r. The cosine of the angle is the adjacent, which now is x, over the hypotenuse, which is r. And the tangent of the angle is the opposite, which is y, over x. Well, if we want to write the reciprocal, the cosecant of angle, remember cosecant is the reciprocal of sine, well, that would just be r over y. The secant, which is the reciprocal of cosine, is r over x. And the cotangent, the reciprocal of tangent, is x over y. Now that allows us to write them in terms of x and y given some point. Now Pythagoras, though, can actually allow us to find a value for that radius. If we do Pythagoras over here, remember Pythagoras, a squared plus b squared equals c squared. So x squared plus y squared equals r squared. So if we want to write that r value, that radius, in terms of x and y, it's just x squared plus y squared, square rooted, and the radius will always be positive. So even though we get a square root, we always do a positive value for the radius. One other piece we need to know is what's called the reference angle. And the acute angle formed between the terminal arm and the nearest x-axis is called the reference angle. Well, what does that mean? Let's look at this example. Imagine we have an angle in standard position of 150 degrees. There's my sketch, terminal arm, 150 degrees. Now the acute angle formed between the terminal arm and the nearest x-axis would be this angle right here. Acute because it's less than 90 and it's between the terminal arm and the nearest x-axis. And this is what's called the reference angle. We're going to refer to that angle. Now it's pretty easy to find the reference angle because if we were to go all the way across, we'd be at 180 degrees. But we're not all the way there, we're just at 150, so some simple subtraction of 180 degrees minus 150 degrees, and there's our reference angle. 30 degrees is the reference angle. Now we can also find the reference angle in radians. So if we're at negative 3 pi over 4 and we want to find the reference angle, well, negative 3 pi over 4, remember, this is 180 or pi. If we're going in the negative direction, this would be negative pi. We don't want a full pi, we want 3/4 of a pi. So a sketch would look something like that. Here is negative 3 pi over 4. Well, the reference angle we want is the angle between the terminal arm and the x-axis. And again, to find that reference angle, we can just take pi and minus 3 pi over 4 and get pi over 4. Now here's the thing about the reference angle. The reference angle is always positive. So regardless of the direction, we don't care whether we're going in the positive or negative direction, the reference angle is always a positive value. Now since we're looking at reference angle, we can add one other piece to this, the reference triangle. And the reference triangle is this triangle that forms a 90 degrees, and the acute angle is inside it, and this is what we call the reference triangle. And we're going to use triangles a lot in trigonometry and use these little reference triangles. And again, the angle is a positive value. Well, what if we want to find out the sine of a trig function? So we have our 3 trig functions here, and it really depends on what quadrant this function lies in. So let's look at this, and we're actually going to work our way through, and then we're going to find a much easier way to remember. Now, we're not concerned about the angle right now. We're just concerned about the sine. Is it positive or negative? So if we look at our axis grid here, here's x and here's y. And in the x direction, this is a positive x direction. Here's the positive y direction. Obviously, this is negative x and the negative y direction. So we want to concern ourselves with the quadrant that we're in. And remember the quadrants, here's 1, here's quadrant 2, here's quadrant 3, and here's quadrant 4. And we most often use Roman numerals there. You don't have to use Roman numerals, but we use Roman numerals a lot. So in quadrant 1, if we had a terminal arm in quadrant 1, so what we have to remember, if we're doing the sine of an angle, sine of theta is y over r. And cos of theta is x over r. And remember, the tan of theta can be written as y over x. And this is why it's important to know which quadrant we're in. If we're looking at the sine of an angle in quadrant 1, the y value that we put in quadrant 1, well, if we're in quadrant 1, we'd be somewhere in here. The y value is going to be a positive number. Now remember, the radius is always positive. So a positive divided by a positive means in quadrant 1, sine is always going to be positive. If we look at sine in quadrant 2, well, in quadrant 2, y is still positive and r is still positive. We'll have another positive. Well, what about quadrant 3? Y is negative and the r is positive, which means we have a negative value in quadrant 3. And what about quadrant 4? Well, negative y, positive r, and we'll end up with a negative. So now we know in quadrant 1 and 2, sine is positive. So now we know in quadrant 1 and 2, sine is positive. In quadrant 3 and 4, sine is negative. Now pause the video and see if you can do the other trig ratio signs for cos and tangent. So there's the solution for cosine. Cosine in quadrant 1 and 4 is positive. In quadrant 2 and 3 is negative. If you haven't finished the tan, again, pause the video and do tan. And there's our values for tan. In quadrant 1 and 3, tan is positive. In quadrant 2 and 4, tan is negative. Now, once we have all this information, we can actually recognize a pattern based on the quadrant. And the pattern we want to recognize is what is positive. That's our concern. What is positive based on the quadrant? Well, if we look at the first quadrant, they are all positive in quadrant 1. All three trig ratios are positive. In quadrant 2, just sine is positive. In quadrant 3, just tangent is positive. And in quadrant 4, just cosine is positive. And this whole activity was to allow us to find a way to easily remember this, an easy way to remember this. And by far the easiest way to remember this is to look at your coordinate grid and remember that in quadrant 1, we have all of the trig ratios are positive. In quadrant 2, sine is positive. In quadrant 3, tangent is positive. And in quadrant 4, cosine is positive. And if you recognize, if we start at C and work our way around, we have what's called the CAST rule. C-A-S-T. If we want to start in quadrant 1, we can also say all students take calculus, a mnemonic that allows us to remember where the trig ratios are positive. Now what we have to remember though is that sine is also associated with 1 over sine, the reciprocal. Sine and cosecant are also positive in the same coordinate. And tan and cotangent are positive, and cosine and secant are positive as well. So there's our CAST rule. Very, very important when we do trigonometry, and we want to find whether values are positive or negative. So let's use this information and see if we can find the sine of an angle if the secant of the angle is negative 3 over 2 and tangent is greater than 0. Tangent is positive. So to start this question, we want to get a sketch of what we're looking at here. So we want to determine what the terminal arm is. Now, the terminal arm uses these two pieces of information. Secant is negative and tangent is positive. If we need to, we'll flip back to our cast rule. Where is secant negative and tangent positive? Well, it's pretty easy to see here that we would be down in quadrant 3. Our terminal arm would put us in quadrant 3. That's where secant is negative and tangent is positive. Now, if we have secant of the angle, secant is negative 3 over 2. And I'm just going to write it out this way. But remember, secant of an angle is the reciprocal of cosine, which means this is hypotenuse over adjacent. Now, that hypotenuse and adjacent is what we'll use for our reference triangle. Here's our reference triangle. Put it in as a 90-degree triangle. And based on our reference angle here of theta, we now know some information about this triangle. Secant is hypotenuse, so the hypotenuse is 3, and the adjacent is 2. Now, because it's negative, the negative here, the negative is always going to apply to the x or the y, so we'll just make that negative 2. And we can also tell it's negative because it's going in the negative x direction. But what we don't know is we don't know the y coordinate in this reference triangle. But the beauty of a reference triangle is we can use Pythagoras to find the unknown value whenever we need to. So we want to find an unknown value here, so we can say y squared plus negative 2 squared is equal to 3 squared. So y squared is going to equal 9 minus 4. Y squared equals 5. And our y will either equal plus or minus root 5. But what we have to recognize in our question is it's negative root 5 because we're in the negative y direction. So now that we have our value for y, we can find any of our trig ratios. What we're actually trying to find is the sine of the angle. And the sine of the angle is, again, go back to SOHCAHTOA, opposite over hypotenuse. The opposite in this case is negative root 5, and the hypotenuse is 3. And there's our solution. The sine of theta is negative root 5 over 3. Now we may have to find a single trig ratio, or we may, like in this second example, have to find all 6 trig ratios. So let's find all 6 trig ratios. Now the important thing in this question is that we're trying to find a terminal arm of an angle theta that contains the point 5, negative 3. Now we have to keep in mind that this is the xy of that point P. So 5, negative 3, if we were doing a sketch, we would go out 5 and down 3, and here is our point of 5, negative 3. Now we have a terminal arm that goes through that point, and it might go further, we don't care. What we are concerned about, though, is the reference triangle. That right-angled acute triangle, because that reference triangle will allow us to write the trig ratios from the reference angle theta. Now the good part about a question like this is that we now know the sides. We've gone 5 in the x and negative 3 in the y. We don't know what the r value is, or the hypotenuse in the reference triangle, but again, Pythagoras can help us out. A squared plus b squared equals c squared. So 5 squared plus negative 3 squared is equal to c squared. We get 25 plus 9 is c squared. So c is equal to, again, plus or minus root 34. But we have to recognize that the hypotenuse is positive, and so our r value is root 34. And now that we have all 3 sides of the triangle, we can write out all 6 trig ratios. So I want you to take a second, pause the video, and see if you can write out all 6 trig ratios from that question. And once you've done your 6 trig ratios, there's the solutions you should get just doing opposite, adjacent, and hypotenuse. Just be careful with sine and cosine here. Both solutions are acceptable. Sometimes we rationalize the denominator, sometimes we don't. Both are perfectly acceptable, but we have opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent, and the reciprocal identities for each. So there's our 6 trig ratios for 1 point on a terminal arm using the reference triangle. And we're going to do more questions like this in class.